Wow, you guys have sent in a ton of articles about genetic engineering. Talk about a topic ripped right from the headlines. Looks like
Mhm.
you're all really interested in CRISPR and cloning and, uh, you know, designer babies, all those ethical questions we have now that we could rewrite our DNA. So, are you ready to have your mind blown?
Well, it's certainly a field that's moving incredibly fast, and it's one that I think has really massive implications for all of us, not just scientists.
Absolutely. And in this deep dive, we're going to be going from cloning sheep all the way to editing human embryos. We're going to be talking about the good and the bad, the potential benefits and the terrifying risks, and of course, the huge impact this could have on society as a whole. But before we even get to all of that, I've got to ask you, did you know that humans share like 50% of their DNA with a banana?
That's absolutely true, although I'm not sure I'd want to be sharing a smoothie with my long-lost banana relative, but I get your point. It really highlights how even these simple organisms that we see every day share a lot of common genetic heritage with us.
Okay, so bananas aside, let's rewind the clock a bit. You're the expert here. Can you give us a quick history of genetic engineering? How did we get from zero to CRISPR?
Well, like many breakthroughs in science, I think it happened in stages. And a lot of people, when they think about genetic engineering, they think about Dolly the sheep, the first cloned mammal back in 1996. And I think that was a real turning point. That's when things really hit the mainstream media and the public started to grasp the potential power of genetic manipulation.
Lolly. I remember that. I mean, it was front page news. It was everywhere. It felt like science fiction had become reality overnight.
Yeah, exactly. And, it was a really complex and delicate process. It was something that had a very high failure rate. It took hundreds of attempts to finally get Dolly, but it was proof of concept. It showed the world that we could actually manipulate these fundamental building blocks of life.
So how did we get from cloning, which already seemed like such a huge scientific leap, to CRISPR?
Well, CRISPR, which stands for Clustered Regularly Interspaced Short Palindromic Repeats, easy to remember. Yeah, but it was a total game changer. So CRISPR is actually a naturally occurring system that's found in bacteria, and bacteria use this system to defend themselves against viruses.
Wait, bacteria have an immune system?
They do, and it's a really sophisticated one. So what they actually do is they store pieces of viral DNA within their own genome, and then they can use these pieces of DNA to identify and destroy invading viruses when they come back. And scientists realized that they could harness this system to target and edit specific genes in any organism, even us.
So bacteria basically gave us a superpower.
In a way, yeah. I
Yeah.
think that's a great way to put it. And what makes CRISPR so revolutionary is that it's precise, it's cheap, and it's accessible. It's like having a molecular scalpel that allows us to go in and target and cut DNA with this incredible accuracy. You can think of it like this. Imagine you have a massive library filled with millions of books, and you want to go in and find a specific sentence in a specific book on a specific shelf and edit it. CRISPR allows us to do that with DNA.
Wow. Yeah, that is a serious level of precision.
It is. And because it's relatively inexpensive and easy to use, it's opened up this whole world of gene editing to a much wider range of researchers than ever before. And that's why it's been hailed as one of the most significant scientific breakthroughs of the 21st century.
It's pretty incredible.
Yeah.
But all this power, all this potential, obviously comes with some pretty serious ethical considerations. I mean, we're talking about altering the very blueprint of life here. Where do we even begin to unpack all that?
Well, that is the million-dollar question. I mean, we've gone from modifying plants and animals to potentially rewriting the human genome. So it's incredibly exciting, but also a little terrifying.
Let's dive into that terrifying part a little bit.
Yeah.
One of the things I read about was the potential for CRISPR to be used for designer babies. I mean, we're not talking
Well-
about science fiction anymore, right? This is a real possibility.
Oh, it is absolutely a very real possibility, and it brings up all kinds of really tough questions. So, for example, back in 2018, a Chinese scientist actually used CRISPR to edit the genomes of twin embryos, trying to make them resistant to HIV.
Right, I remember that. That was a huge controversy. He ended up going to prison for that, didn't he?
He did. It was considered a major ethical breach. And I think it really underscored that we're still grappling with the implications of this technology.
It's understandable. I mean, on the one hand, you have this potential to eradicate genetic diseases, which is amazing. But then, where do we draw the line? Where's that slippery slope to designer babies?
Exactly. Yeah, that's the question. What traits are considered enhancements? Who decides what's desirable and what's not? And what about the unintended consequences? We really need to figure that out before we go too far down this road.
Okay, let's talk about unintended consequences. Another article you sent focused on the potential for CRISPR to be used for bioweapons.
Right. And that is one of the darker possibilities that we need to consider. I mean, imagine a virus that has been engineered to target people with certain genetic markers. You could theoretically wipe out entire populations.
That sounds straight out of like a dystopian thriller.
It really does. But it's something that defense agencies around the world are actually taking very seriously. I mean, I read that DARPA, which is the Pentagon's research arm, is already investing heavily in this area, researching genetic bioweapons and countermeasures.
So this is a real threat. This is not just theoretical.
Not at all. I mean, look, this technology is powerful. It cuts both ways. It has the potential for great good, but also for unthinkable harm.
So where does that leave us?
I think it means that we're at a really pivotal moment in human history. This technology is still in its early stages, but it's evolving rapidly, and we really need to have some serious conversations. We need to figure out the ethical implications. We need to have some safeguards in place before it's too late.
That's a pretty sobering thought. But before we all spiral into an existential crisis, let's zoom out a bit and look at some of the larger scenarios. One of the articles you sent me paints a pretty plain picture of what could happen if this technology falls into the wrong hands.
I think that's a really good point. I think it's important to explore those possibilities, even if they make us a little bit uncomfortable.
So imagine a world where, let's say, the wealthy elite can use CRISPR to create what they see as enhanced children.
It's interesting, isn't it? A world where things like intelligence, athletic ability, maybe even physical appearance are no longer left up to chance, but are actually determined by genetic engineering.
And of course, those enhanced individuals would have this massive advantage in every aspect of life, right? They do better in school, have an easier time getting jobs, just about everything.
It's a scenario that science fiction has explored for a long time. But I think it's now becoming much more of a real possibility, and the implications are pretty profound.
I mean, we're talking about a level of inequality that we haven't really even seen before. Not just economics, but a fundamental difference in human capability.
That's right. And I think that kind of disparity could lead to social unrest on a scale that we haven't seen. It's not hard to imagine. I mean, imagine the resentment and anger of those who are left behind in a world where the genetically enhanced have all the advantages.
Right. And it's not just about, one country or one group of people. I mean, imagine entire nations competing to create genetically enhanced soldiers.
Mm-hmm.
Or even worse, developing bioweapons that can target specific populations based on their DNA. I mean, the potential for conflict is pretty enormous.
Yeah, it's definitely something we need to think about very carefully.
So this is a pretty bleak picture you're painting.
Yeah.
Are there any positives we should be thinking about?
I mean, I will say that there are some who argue that we have a moral obligation to explore the full potential of this technology, especially when it comes to treating or preventing diseases.
So using CRISPR to cure inherited conditions.
Exactly. Things like cystic fibrosis, Huntington's disease, muscular dystrophy, devastating conditions that cause immense suffering.
I get that. I mean, it's hard to argue against trying to prevent that kind of suffering.
Yeah.
But even if we only focus on the medical applications, there are still ethical gray areas.
Right. Of course. Absolutely. I mean, where do we draw the line between, therapy and enhancement? If we can use CRISPR to cure a disease, can we also use it to make people taller, stronger, smarter? And who gets to decide what's considered a disability or an enhancement?
These are all great questions. And it doesn't seem like there are any easy answers.
I don't think so. I think that's what makes this such a complex and challenging topic to think about. Any powerful technology can be used for good or for bad. It all comes down to the choices we make.
Okay, well, I think we've given our listeners a lot to chew on already. But before we go any further, we'll have to take a little break. We'll be right back to continue our deep dive into the fascinating and sometimes frightening world of genetic engineering.
Welcome back. We were talking about some pretty heavy stuff there before the break. Genetically enhanced elites, designer babies, bioweapons. It's a lot to take in.
It is. But you said it yourself. It's important that we face these possibilities head on, right? I mean, ignoring them isn't going to make them go away.
Exactly. We can't make informed decisions about this stuff if we're not even willing to consider the full range of outcomes, the good and the bad.
Right. Okay, so let's shift gears a little bit and talk about some of the philosophical questions that this technology raises. One of the articles that you sent me asked this really interesting question. What if we could actually use CRISPR to, eliminate aging from our DNA? Would we even want to live forever?
Now that's a question that has been around for centuries. I mean, philosophers and poets have been wrestling with the idea of immortality forever, haven't they?
And for good reason.
Yeah.
I mean, it is a seductive idea, but also kind of terrifying at the same time.
Absolutely.
I mean, on one hand, think of all the things you could do if you had unlimited time. All the knowledge you could acquire, the places you could go.
I mean, you could witness the rise and fall of civilizations, travel to distant galaxies. You could master every art form imaginable.
Right. But would life even have meaning if there were no end to it? Would we just end up becoming complacent or reckless?
Yeah.
Or just bored?
Right. And what about the implications for society? I mean, you'd have overpopulation, resource scarcity. You could even end up with, some kind of tyranny as people in power cling to that power for generations.
It really makes you wonder if we're messing with forces that we don't understand. I mean, are we playing God here? And if we are, do we even have the wisdom to handle that kind of power?
That's the question at the heart of this whole debate, isn't it? We've unlocked the secrets of our own genetic code, and with that knowledge comes tremendous responsibility. But are we mature enough? Wise enough? I don't know.
Maybe this focus on immortality is the wrong approach. What if instead of trying to live forever, we focused on just improving the quality of our lives?
I think that's a really good point. What if we used CRISPR to address the underlying causes of aging and age-related diseases?
Like Alzheimer's and Parkinson's and heart disease?
Exactly. Imagine if we could eliminate those. We might not achieve immortality, but we could potentially live much longer, healthier lives.
Okay, that makes a lot of sense. But even if we set aside this whole idea of living forever, we still have a lot to consider. I mean, if we can change any part of the human blueprint, intelligence, empathy, creativity, what if we could engineer ourselves to be better? I mean, would we even want to?
It's tempting to think about, but who gets to decide what better even means? Whose values are we encoding into our DNA? And what about the traits that we currently see as negatives, like sadness or anger? Would we want to eliminate those too?
I mean, that starts to sound a little dystopian, doesn't it? Like we're trying to create some kind of perfectly optimized human machine devoid of all emotion.
Yeah, I think that's a valid concern. I think we have to be really careful that, our quest for perfection, we don't lose sight of what makes us human in the first place.
Okay, so we've talked a lot about these big philosophical implications, but let's get practical for a second. I mean, this is all mind-blowing, but for the average person listening right now, what does it mean for them? What can they actually do?
Well, first of all, I think it's just important to stay informed. I mean, this is a field that's moving so fast. New discoveries are being made all the time, and it's important to keep up. Read articles, listen to podcasts like this one. Just stay engaged and informed.
Okay, so read and listen. What about specific resources? Are there like organizations or websites that you would recommend?
Yeah, absolutely. The Human Genome Project is a great place to start. They've got tons of info on their website about genetics and genomics and, the ethical, legal, and social implications of this kind of research.
That's a good one. And what about CRISPR specifically? Are there organizations or companies that are sort of, leading the way in this area?
Yeah, there are actually a lot of really interesting CRISPR startups out there. Companies like Editas Medicine, Intellia Therapeutics, CRISPR Therapeutics, they're all doing really cutting-edge work developing therapies for a wide range of diseases.
So if people want to really nerd out, they can actually see how this technology is evolving in real time.
Absolutely. And, that brings me to probably the most important thing that you can do. Engage in the conversation. Talk to your friends, your family, talk to your elected officials. The ethical implications of this technology are huge, and we all need to be part of the conversation. Don't wait until decisions are being made without your input.
Because this isn't science fiction anymore, right?
Yeah.
This is really happening, and it's going to impact all of us.
Absolutely. I think the future of genetic engineering is being written right now, and we all have a role to play in shaping it.
Okay, so before we wrap things up here, I want to circle back to something you said earlier about unintended consequences. We're talking about tinkering with the very building blocks of life here. It seems like there's always a chance that something could go wrong.
You're absolutely right. No technology is without risk, and CRISPR is no exception. One of the biggest concerns with CRISPR is something called off-target effects.
Off-target effects? What does that even mean?
Well, it means that the CRISPR system might actually edit genes that weren't meant to be targeted.
So like accidentally deleting the wrong file on your computer?
That's a great analogy. And just like deleting the wrong file can cause problems with your computer, off-target edits can cause unintended consequences for the organism, for its health.
Okay, so how do scientists try to minimize those risks?
Well, one way is just to improve the precision of the CRISPR system itself. I mean, researchers are constantly working to develop newer versions of CRISPR that are more accurate, less likely to cause those off-target edits.
So kind of like upgrading your software to like a newer, less buggy version.
Exactly. Another important safeguard is just rigorous testing. Before any CRISPR therapy can be used in people, it has to go through a whole bunch of safety testing in animals, in the lab, making sure it's both effective and safe.
So, okay, so there are some measures in place to try to prevent things from going wrong.
Yeah.
But even with all the testing and all the precautions, there's still a chance that something could slip through, right?
Yeah, there's always that chance. I mean, these are incredibly complex biological systems that we're dealing with, and it's always possible that something unexpected could happen.
It's like that old saying, life finds a way.
Exactly. We can try to control nature, but it has a way of surprising us.
So how does that make you feel about the future of CRISPR? Are you optimistic? Pessimistic?
I think it's important to be both. I think we should be excited about the potential of this technology, to cure diseases, to improve lives. But I think we also need to be realistic about the risks. And we need to proceed cautiously. This is a very powerful tool. We need to use it wisely.
Well said. So we've covered a lot of ground here today. We talked about the history of CRISPR. We talked about its potential benefits and its risks. We talked about some of the ethical challenges that it poses. But there's one question that keeps coming back to me. If we have the power to actually rewrite our own destiny, what kind of future do we want to create?
That's the big question, isn't it? The most important question we have to ask ourselves.
So where do we go from here? What are the next steps?
Well, I think we just have to keep having these conversations. We need to educate ourselves about the science, about the ethics, about the potential impacts of this technology.
And make our voices heard, right? Let our elected officials know where we stand on this.
Exactly. The future of genetic engineering is not set in stone. We get to help decide what it looks like.
Okay, well, this deep dive has been fascinating. And yeah, a little bit unnerving at times. I think our listeners have a lot to think about. But before we leave them with too much existential dread, let's try to end on a hopeful note.
I like that. Despite all the challenges, I do believe CRISPR has the potential to be a force for good in the world. And I think it's up to us to make sure that that happens.
A force for good. I like that. Okay, so last question. What's the one thing you really want our listeners to take away from this deep dive?
I want them to understand that the future is not something that just happens to us. It's something that we create together. So let's make it a future worth living in.
Well said. And folks, if this has sparked your curiosity, please don't stop here. Keep learning, keep asking questions, keep engaging in the conversation. The future is in our hands. Let's make it a good one.
It really is. It does feel like we're at kind of a crossroads, doesn't it, with this whole thing?
Yeah. It's both exciting and scary at the same time.
Mm-hmm.
But before we wrap up, there's one more thing I wanted to touch on. This idea of rewriting destiny, Can we really control our future by messing with our genes?
I think it's a really tempting idea to think that we can just sort of eliminate disease and, enhance our abilities, maybe even cheat death. But I think we have to remember that nature is incredibly complex. And even with all of our technology, we're just scratching the surface of understanding how it all works.
So even if we edit our genes, we can't really predict all of the outcomes.
Exactly. There's always the potential for these unintended consequences. I mean, think about it. Evolution has been tinkering with our DNA for millions of years.
Right.
And it's created this incredible tapestry of life, full of diversity and resilience.
So you're saying like messing with that could have ripple effects, like things we can't even imagine.
That's exactly right. We might think we're improving things, but we could be inadvertently introducing vulnerabilities or disrupting some kind of delicate balance that we don't even fully understand. It's like trying to edit a complex ecosystem. You pull on one thread and the whole thing could unravel.
It's kind of a scary thought.
It is. And it's why I think we need to proceed with a lot of caution, a lot of humility. We have to respect the complexity of life. I don't think we should abandon this technology, but I think we need to be very mindful of the potential consequences of our actions.
For sure. Well, this has been an incredible deep dive. We've gone from the history of cloning to the possibility of designer babies, the hope of curing diseases, to the threat of bioweapons. I feel like we've only just scratched the surface here, but hopefully it's given everyone listening a lot to think about.
Yeah. I mean, the future of genetic engineering is unfolding right now,
Mm-hmm.
and the choices that we make today are going to have a huge impact on the generations to come.
So what's the one thing you really want our listeners to take away from all this?
I want them to remember that the future is not something that just happens to us. It's something we create together.
Yeah.
So let's make it a future where science and ethics go hand in hand, and where we use this knowledge to try and build a better world for everybody.
Well said. Everyone listening, if this deep dive has sparked your interest, please don't stop here. Keep learning, keep asking those tough questions, and keep engaging in the conversation, because the future is in our hands. Let's make it a good one.